Hello grade 11, once again we are consolidating this term. You have been working consistently, so we're just going to do some quick revision on the work that we have done so far. Okay, right, I'll keep on, I'm just giving you the questions, I'll keep on telling you what you are expected to be doing in that particular question. This is an inequality question, and we have to write it in a quadratic format. Remember we said this is quadratic inequalities, all right? So quadratic, it's always in a form of ax squared plus bx plus c equals to naught, right? So this is your standard form for a quadratic, all right? So before you work with your problem, remember we said your inequalities, it's either you have a less than or greater than, or less or equals to, or greater or equals to, right? Now, I'm going to give you this problem because we just did this work together. I'm going to give you this problem and you work. I'm giving you 3 minutes to work on this problem, and then from there, we're going to do it together, right? So take this problem, 3 minutes, and then we share the answers. Well done, guys. But there are some of us that are still tempted to say, this is 3x squared minus 20 minus 7x greater or equals to naught. Transposing the 7x, which is correct, but it's not in this form, ax squared plus bx plus c. And again, you will be tempted to say, okay, now I can factorize quickly 3x, x, 7, and 1, and so forth. And then you see that this is 21, and then that's 1, then you get a 20. But this is not in your quadratic format. Okay, now let's do the right thing. You will have 3x squared minus 7x minus 20 greater or equals to 0. Okay, then next you factorize. Then you have your 3x, and then your x, then 4, and then 5. You have a minus here and plus. Guys, please make sure that you check if it works out. If you multiply, are you going back to the original one that's given, which is 3x squared minus 7x minus 20. Okay, and then from there, we don't just go and say x is minus 5 over 3 or x is 4. Those are your critical values. This is an inequality. Okay, so you can have your rough parabola sketch, which is minus 5 over 3, the first one, and then 4. This parabola is positive. Your a is greater than naught. But now you're looking for positive, okay, above the x-axis. So you're reading off your graph here and also there, right? So in other words, our solution here is, therefore, our x is less or equals to minus 5 over 3, or x is greater or equals to 4. So that is your inequality. Right, now be reminded, if it was less or equals to, and then for instance you get a situation like this, then your x is in between those two values of x. Okay, right, now when we checking what we've done up to so far, beginning of the year up to today, that you did some roots, nature of roots, and so forth. The next question touches on the nature of roots. Okay, the two roots of the equation 4x squared plus px minus 9 differ by 5, calculates the value of values of p. All right. Now, let's just think through this problem, okay? You have the roots of that equation, and if they're saying they differ by 5, for instance, if one root is 2, so it means the other one should be a 7. So the difference between the two is 5. Okay, just making that example. But now you've got 4x squared plus px minus 9 equals to 0. How do you get the roots there? For me, it is impossible to factorize this because of the p, right? So I can either use completing a square first or using the quadratic formula. The one that's easier here is to use a quadratic formula. So x is minus b plus or minus square root of b squared minus 4ac all over 2a. All right. So now, how do we get the roots here? So x is your b, in this case is p, so minus p plus or minus the square root of p squared minus 4, your a is 4, and then your c is minus 9, all divided by 2, and your a is 4, right? Then that simplifies to minus p plus or minus the square root of p squared plus, now your 4 times 4 times 9, it's 144. So that is 144 all divided by 8. Now, so this is how we work out the roots of this quadratic equation. Now, but we have not yet answered the question. They're saying the two roots, okay? So in this case, what are the roots? It is minus p plus root p squared plus 144 over 8 and minus p minus square root of p squared plus 144. but they differ. Their difference is 5. So if I subtract one from the other, I should be getting a difference of 5. So now if we take one, for instance, we have this root minus p plus the square root of p squared plus 144 all over 8 minus, okay, the other root is minus p minus square root of p squared plus 144 all over 8. What is the difference? That the difference is 5. Okay, so now what is left of us is to simplify and work out what the value of p is. Okay, so you get minus p plus the square root of p squared plus 144 divided by 8. Then that negative times negative, that's a plus p. Then you've got that negative again multiplied by that negative plus the square root of p squared plus 144 all divided by 8, which is equals to 5. Now, guys, if you were to check, your LCD here is 8, okay? So everything is divided by 8. So you can say it's all over 8, and to get rid of the denominator, you're going to multiply each and every term with the denominator, okay, which is 8. Now, if you check your numerator, you'll have minus p plus p, which gives us a 0. The square root of p squared plus 144, square root of p squared plus 144, those two are like terms. So you're going to get 2 square root of p squared plus 144 equals to 8 multiplied by 5, that it gives us 40. And then you've got your square root of p squared plus 144 equals to 20, dividing by 2 throughout. And then now again it goes back to what we've been doing from the beginning of the year, your sets, right? Squaring on both sides. Now remember, if you square on your left, that's 2, which is that half multiplied by that 2, it cancels out. So you have to square on both sides, all right? And now we get p squared plus 144 equals to 400, okay? Then you have your p squared equals to, now you guys are quick, but I'm a little bit slow now, I'm getting old. 400 minus 144, that's 256. So you get 256. Now, guys, remember, once you get to this point, your p squared is 256. So it means that there are two possible values of p, all right? So you can either do the difference of two squares, or you find the square root. So this will be the square root. Now remember, it's plus or minus. So your p is plus or minus 16. So the value of p is plus or minus 16. Now, if you were to check 4x squared plus px minus 9, 4x squared plus px minus 9 equals to 0. It is plus or minus 16. So if you were to put 4x squared plus 16x, maybe minus 9 equals to 0, and then you factorize, then you've got to 2x, 9 and 1, plus and minus. So your x is half, or x is negative 9 over 2. And then you check with your values, if you've answered the question, what is the difference between the two roots? How do you work out the difference, one minus the other? So you'll have a 1 over 2 minus 9 over 2. You get a half plus 9 over 2, which is 10 over 2. So it means that you are correct if you are getting p equals to plus or minus 16, because you still get the difference to be 5. So it was quite a long question, but we have answered what they needed us to do. All right, so we found the value of P. All right, guys, we're going to go for a break, get some water, and then when we come back, we'll continue with some other things that we've been doing through the term. Welcome back, grade 11s. We're now looking at your number patterns, sequences, and series. Remember, we spoke about the linear, the quadratic, your geometric, exponential, and whatnot, and just looking at the patterns and coming up with conjectures. Okay, so the question that I have here for you, it talks about a quadratic pattern, all right? So a quadratic pattern has a second term equals to 1, a third term equals to -6, and the fifth term equals to -14. Calculate the second difference of this pattern and hence calculate the first term. All right, so now look at the mark allocation. Okay, guys, so it means that with that much marks, so there's quite more work to do. All right, so what I'm going to ask you to do in the next 3 minutes is to work out the pattern itself, right? Sort out, take this wording, English to mathematics, and then from there we work out the solution of this problem. So I'm giving you this time, 3 minutes, to set up, and then from there we work with this problem. Okay, take 3 minutes. All right, grade 11s, let's just check if we are on the right track. In setting up, okay, we are told this is a quadratic pattern, all right? how does a quadratic pattern look like? It should be in a form of an squared plus bn plus c, right? Okay. Now, what we know about a quadratic pattern is that it has got a second difference which is constant, okay? Right? So if the second difference is 2, it's going to be 2 throughout. But now let's check. You've got a quadratic pattern that has a second term equals to 1. All right, so this is our second term, right? We don't know what the first term is, so we can just assign it x, right? Now we move on. A third term equals to minus 6, right? A third term is minus 6. And a fifth term, now again, we don't know what the fourth term is, so we can just give it y. And then the fifth term is minus 14. Calculate the second difference and also find the first term. All right, so now how do we get to the second difference? Right, so our first difference here, remember what we do is, to get the first difference, we say term number 2 minus term number 1. Remember, this is term 1, term 2, term 3, 4, and then term 5 as it is given. All right, so that you can work out the differences there. So you have term number 2 minus term number 1 is 1 minus x, okay? And then term 3 minus term 2, that's minus 6 minus 1, which gives us a negative 7, all right? And then term 4 minus term number 3, that's y minus minus 6, which is y plus 6. And then term 5 minus term number 4, that's minus 14 minus y. So we've got our first difference there, all right? Now, to work out the second difference, we do the same. So this 1 minus x serves as our term 1 of the first difference, minus 7, y plus 6, and on, all right? So now, how do we work out the difference here? You get to minus 7 minus bracket 1 minus x. Okay, I'm going to just work it on the side for you guys. It's minus 7 minus bracket 1 minus x. So that is minus 7 minus 1 plus x. So you get x minus 8. All right. So that is x minus 8 or minus 8 plus x. Then on to the next one. You have your y plus 6 minus bracket minus 7. Right. Y plus 6 plus 7, which gives us y plus 13. So that will be your y plus 13. Now let's look at the last one. You have your minus 14 minus y minus, remember guys, you are subtracting the whole term. So it's minus y plus 6. So that is minus 14 minus y minus 6, which gives us minus 20 minus 2y. So we've got minus 20 minus 2y. Okay, right. Now, guys, we have worked out the first difference, and now we are on to the second difference. But now what should be coming to our minds is the second difference, because we are told that this is a quadratic pattern. The second difference is the same throughout. So in other words, your x minus 8 should equate to y plus 13, or your y plus 13 equals to minus 20 minus 2y. All right? So now, you look at your second difference, and the easier one to work with is the y plus 13 and minus 20 minus 2y. Why am I saying it's easy? It's because now if you equate the two, you're going to get 1y. There's only one unknown that you'll be working with, okay? But when you come to this one, the x minus 8, equating it to y plus 13, then you'll be having two unknowns, and you might have to work with that, and then it becomes longer, and you have to go to simultaneous equations. All right, so we work with the second one and the third one. All right, so now the second difference is the same throughout, so you'll have your y plus 13 is equals to minus 20 minus 2y. Okay? Collect your like terms. You've got y plus 2y. It's minus 20 minus 13, which gives us 3y equals to minus 33. Therefore, y is minus 11. All right. Now, so guys, what happens here is now, just leave this one open. You now have the value of y. And your second difference, if I may write it here, you still have that x minus 8, right? And then the y plus 13, now in the place of y, you can sub in the minus 11. So you've got minus 11 plus 13, you get a 2, all right? Now, if you now substitute here, you've got a minus 20, minus 2 bracket minus 11, which gives us minus 20 plus 22, and then you've got 2 there. Now, guys, if you check, you've got x minus 8, 2, and 2. So in other words, it means that your second difference, which is constant now, it is 2. All right? So you have answered the first part of the question, which is the second difference equals 2 to 2. Okay? Now, let's proceed. So we've got the first part of the solution. Now they said work out the second difference and also from there work out what your term 1 is. Okay, so now from there, as we know that this should be equals to that and also equals to that, so therefore your x minus 8 is equals to 2, then x is 10. All right, so x equals to 10. If you were to go back, you sub in there, x is 10. Right, so you have answered your term 1. Now, guys, remember, after this, you can be asked to determine the general term for this particular pattern. Now, you have 10, 1, minus 6. So you've got 10, 1, minus 6, minus 11, and the last one was minus 14. Then it's easy to work out the differences. That's minus 9, that's minus 7, and then that's minus 5, minus 3, and then you've got a 2, a 2, a 2. All right. Now, guys, when you're working out the general term for a quadratic pattern, you know that at the end of the day, it's going to be written in the form of Tn equals to an squared plus bn plus c. But we spoke about another formula again here, whereby we said this part, this is your term 1, this is your f, and then this is your s. So Tn is T1 plus n minus 1, f plus n minus 1, n minus 2 divided by 2 times s. And then the only thing that you need to do is to substitute. So Tn is 10 plus minus 9, right, n minus 1 plus your n squared minus 3n plus 2 divided by 2 times that 2 which divides, and then you get your 10 minus 9n plus 9 plus n squared minus 3n plus 2, which gives us the n squared minus 12n, right, plus 19 plus 21. You can just double check for me. Or you use that a plus b plus c, your 3a plus b, and your 2a equals to your second difference. You will get to the same answer. All right, so with this question, as we have been asked, we needed to work out the second difference and also the first term, and then I just added to you what they can also ask you is to determine the general term for this particular pattern, and you're reminded that your quadratic pattern is in the form of Tn equals to an squared plus bn plus c, and then you know that you can either use for term 1 a plus b plus c equals to your term 1, your 3a plus b equals to your first difference of the first term of the first difference, and then your 2a equals to your second difference. All right, guys, again, we're going to take a short break, and then we come back, we continue with what we've been doing since the start of term 1. Welcome back, grade 11s. We now continue consolidating what we have been doing since the start of term 1. We also did your analytical geometry, whereby you needed to work out the gradient, your straight line, the difference between your parallel lines and your perpendicular lines, and then also the distances, right? You just reminded of those terminology, your midpoint and so forth. All right, so here I've got a question in the diagram below. P minus 4 and 4, Q1 and minus 2, and RK minus 4 are 3 points on the Cartesian plane. All right, so we have, let's just look at those points. We've got P minus 4, 4, and then Q 1 minus 2, and then K minus 4. So just familiarize yourself with this diagram because I don't have it in the other sides. Yeah. Let's now look at the questions. Determine the length of PQ. All right. So you need to work quickly, guys. It's 2 marks. I'm giving you 2 minutes as well. You're working out the length of PQ. I'm going to show you. I'll leave your diagram open. You need to work out what PQ is, right? So PQ, right, there you go, 2 minutes, let's work. All right, grade 11s, let's just check if we're doing the correct thing. All right, we need to work out the length of PQ, right? Let's just take the coordinates, okay? P is minus 4, 4. Q is 1, minus 2, okay? P is minus 4, 4, and then Q is 1, minus 2. All right. We know that the distance is worked out given the formula PQ. It's x at q, so x2 minus x1 all squared plus y2 minus y1 all squared. Then you get your PQ is the square root of. Now remember guys, you can say this is your first set of coordinates, that's your second set. So it means that this is your x1, that's your y1, x2, y2. Let's not mix. If you're taking from the set 1, use the set 1 coordinates. That is your x1, your y1. So x2 is 1, minus x1, it's minus 4. Then you square the results, plus y2 is minus 2 minus y1 is 4. Then that is squared. So your PQ is the square root of, now 1 plus 4 squared, that's 25, plus minus 2 minus 4, that's minus 6, but minus 6 times minus 6, that's 36. Okay, so then your PQ is the square root of 61, but we work in this distance, so PQ is square root of 61 units. Okay, so well done to you guys who've got it right. So your PQ is the square root of 61 units. Okay, right. Now, determine the coordinates of M, the midpoint of PQ. Now remember, the midpoint is that point halfway through between those 2 points, which is your P and Q. Now let's just go back. It's minus 4, 4, 1 minus 2, right? Minus 4, 4, and then your Q, 1 minus 2. So this one is, it's very quick, guys. Giving you only just a minute. Please work out the midpoint, and then I'm helping you to check if you're correct. All right, guys, let's now check. You've got your midpoint, right? Now remember, for the midpoint, you use your x1 plus x2 all divided by 2 is to y1 plus y2 all divided by 2. Right? Again, remember, you can give them a name. This can be your set 1, and then this is your 2. So it means this is x2, y2, x1, y1. So your midpoint will be your x1, 1 minus 4 over 2 is to your y1 minus 2 plus 4 divided by 2, which in this case, it does not matter that much. Okay, so m is minus 3 over 2 is to 2 over 2, which is a 1. So your midpoint is negative 3 halves and a 1. Okay, so there you go. You've got your midpoint, which is negative 3 halves and a 1. All right. So now let's look at the next problem. Okay. Now, determine the equation of the perpendicular bisector of PQ. All right. Now we need to work out the equation of a perpendicular bisector, and it is 4 marks. Now remember, this is the line that we're working. All right, so your line RM, and you are told that this is a perpendicular bisector of PQ. All right, so now find the equation of that line. You've got 3 minutes. Let's work out the equation of this line. Let's quickly work in groups, and then we can do this together after. All right, guys, let's check if we're doing the right thing. Okay, we needed to work out the equation of a perpendicular bisector of PQ. Now, if we had this coordinate, if this was not an unknown, we were going to say, okay, because I've got point M and also R, I can work out the gradient there, a change in Y over change in X, and then get the equation, all right? But now, because we do not have that, we have that line which is perpendicular to the perpendicular bisector. We can work out the gradient of this line, okay? So we know that the gradient is given by change in Y over change in X, okay? So that's 4 minus 2, which is plus 2, divided by minus 4 minus 1, and that gives us minus 6 over 5. And what is it that we know now about the perpendicular bisector? I mean, the perpendicular lines, is that the gradient of the first line times the gradient of the second line equals to minus 1, okay? Now, so gradient of the perpendicular bisector, I'll just write PB, equals to 5 divided by 6. Now, watch what is happening. Remember, when we're looking at your analytical geometry, is that you've got M1 times M2 equals to minus 1. If your M1 is half, then it means that your M2 will be minus 2 over 1, right? If it was 3 over 4, then the new one will be 4 over 3, but then change of the sign. Okay, so now we've got your gradient of the perpendicular bisector, which is 5 over 6. And the equation of a line is given by y minus y1 equals to m into x minus x1. Now, where are we going to get this x1 and y1, right? So the point that is clear on that line is point M, which is minus 3 over 2 and 1, okay? So you now going to say y minus 1 equals to, your M is 5 over 6 bracket x, your x is minus 3 over 2, so you've got minus 3 over 2. Okay, right? Then you've got your y minus 1 equals to 5 over 6 x. Now watch, guys, you've got a minus, that's a minus minus. So you've got minus minus, which is a plus 3 divided by 2, which gives us, now remember, you have to write your equation in a standard form. So you've got 5 over 6x plus 3 over 2 plus 1, which gives us y equals to 5 over 6x plus, that's 3 over 2. You can help me with my calculation there, but then that's the way you go about your equation of a line. So y equals to mx plus c as your equation, standard form of your equation. All right. So now we move on to the next problem. Calculate the value of k if PR is equals to QR, right? Now we need to work out what the value of k is if PR this it's equals to that. All right. So now what's going to be easy to do is to work out the distance of PR. You compare it with the distance of QR. So now let's just quickly see how we start this off. All right. Now the distance of PR will be k minus minus 4, so it's k plus 4, right, all squared, plus minus 4 minus 4, right? Now we are told that these are equal, so your two lines, your RQ and that PR, it's the same. So you've got your k minus 1 squared plus your minus 4 plus 2 all squared. And then now, guys, it's going to be very easy to work out the value of k from here, right? Let me just do one last step for you. K squared plus 64 equals to k minus 1 all squared plus 4, right? And then from there, you can easily work it out, guys, and work out what the value of k is. You'll expand the k squared plus 8k plus 16, and wish you luck. Because of time, I'm leaving it to you guys, and next time we might have to just check where we've gone wrong or right. Thank you very much for tuning in. See you next time.